again, still not drawn to scale. Our adrenal gland sits on top of our kidney. And as we've talked about, it has a chewy nougat center and a candy-coated shell. What do we call that central region? Medulla. And what do we call the outer region? Cortex. Cortex, excellent. So, it is a triangular shaped structure, like the one they have here. This one happens to be upside down, and I don't have a good answer as to why they decided to put it on the screen that way. But they often make some unique decisions on how they organize these things. Right? The important thing to remember about that, though, is we are always going to talk about going from superficial to deep. Right? And the easiest way to distinguish that is, much like many of the other structures we talked about, like the lymph nodes, like the spleen, there is a fibrous capsule. On its outer surface. And so that would be the most superficial point. I make a point of emphasizing this because even more confusing than having this upside down is what they did on your chart back here. If you look closely at our chart here, you can see our adrenal gland. And if you look really close, you can see that there's a rectangle that they took out of the bottom. So superficial, the fibrous capsule is down here. And then we have the cortex, and then we have the medulla. Most of the illustrations from textbooks and stuff like that have superficial on top, and then deep down at the bottom. They've done that the opposite. I'm purposely doing this right and left, just to emphasize to you that the orientation doesn't matter. The way you're going to orient yourself is by looking for the fibrous capsule. When you find the fibrous capsule, then you know that is superficial, and you know this is going to be the cortex. And this is going to be the medulla. All right? So the medulla is always deep, and our fibrous capsule is superficial. All right, so far so good? Now, if you look here, we certainly see that. This region in here is the medulla, and this region out here is the cortex. But does the cortex all look uniform? No, in fact, there are 3 distinct regions or zones in the cortex. Each of those produce histologically look different. Each of them produce a completely distinct class of hormones. So if we look closely at this, and let's change our view a little bit. We're superficial on this image. Top right corner, exactly. Top right corner, there's our fibrous capsule. That is superficial. And so this is deep. Here is our medulla. Oh, let's go back. Not only are they different in their chewy nougat center, candy-coated shell, but the medulla is also nervous tissue. Whereas the cortex is glandular tissue. And this glandular tissue, the cortex of our adrenal gland, is one of the main places where we're going to produce steroid-based hormones in the cortex of the adrenal gland, so they're called corticosteroids. Overall general class. All right. Let's turn the lights back off to get a better view of this. As we said, this glandular tissue in the cortex basically has three distinct regions, three distinct zones. The most superficial has more of these kind of ball-shaped glandular structures. So it is known as the zona glomerulosa. Like the ball-shaped glomerulosa we saw in the kidney. Notice in the middle region, we have more straight, linear type of secretory structures, kind of more parallel, like the fascicles we saw in muscles, which is where it gets the name zona fasciculata. And the deepest region, notice, is also more linear, but it's not parallel. So it kind of has more of an interlacing kind of mesh-like appearance, kind of like reticular fibers kind of do, a web or mesh-like structure, which is why it's the zona reticularis. We see this nicely in the histology, and here we see another view where it shows it with the histology, but it also does a nice job of showing us the simple illustration for this as well, where we have the ball-shaped secretory structures in the zona glomerulosa, the more linear in the zona fasciculata, the more mesh-like in the zona reticularis. And then we have that nervous tissue in the medulla. And I guess I implied it, but let's make sure we appreciate that. Remember, these corticosteroids are just in the cortex. Not only is the medulla nervous tissue, so it's a different type of tissue, but it also produces amino acid-based hormones. So we have our basically 4 regions in the adrenal gland, each with its own name, and let's just go ahead for consistency. Medulla. Each are going to produce hormones. And as I mentioned, each of these zones produce a different class of hormones. The zona glomerulosa produces a class of hormones called mineralocorticoids. With a name like mineralocorticoid, what do you think that's involved in? Minerals, basically regulating our electrolytes. The zona fasciculata produces a class of hormones called glucocorticoids. With a name like glucocorticoids, what do you think they play a role in? Yeah, this plays a role. But didn't we just talk about the insulin and glucagon? Isn't that really what helps us regulate glucose? Say again? Well, but Not a bad guess. I like that. But if you think about it, insulin and glucagon also deal with how much glucose is in the blood. The key to this one, as we talked about before, is this is about mobilizing glucose, but in response to stress. Right? This is about mobilizing our resources to help us to deal with stress. So this is about mobilizing resources like glucose with stress, or when dealing with stress. And the zona reticularis produces a class of hormones called gonatocorticoids. With a name like that, what do you think it has to do with? Yeah, this is basically involves our reproductive hormones.
Is it regulated then? Is that their function?
We'll work towards it.
Okay.
We're building there. I just want to talk about the classes, and then once we talk about, now that we've done this, we'll talk about each section, talk about it in more detail, talk about specific examples, and talk about how it's regulated. All right? So that is the game plan. Let's look at some of these. Now, I'll warn you right now, I like these pictures from your textbook because I think they do a good job of actually illustrating how this glandular tissue looks. However, I fully appreciate that out of context, there's no way that looking at this that I would think, oh, that's the zona glomerulosa. So if I show you the adrenal gland in any fashion, it will be in a full view of all four sections. So it'll be something like this, or something like this, or something like this, or like the one on the wall. Something along those lines where you can see all four regions in context with each other. Right? I will not show you one of these individual zones just by itself like this. But I'm going to do it here in lecture just simply because I think it gives us a good view of how we can see, oh yeah, those are kind of ball-shaped glandular structures that we see in the zona glomerulosa. All right? All right. As I mentioned, it produces a class of hormones called mineralocorticoids that help us to deal and regulate our electrolytes. The most common specific hormone is aldosterone. And if mineralocorticoids in general help us to regulate electrolytes, and aldosterone is our most common mineralocorticoid, it must help us deal with our most common electrolyte. So what do you think it regulates?
Sodium.
Exactly. Aldosterone regulates sodium levels. And of course, but let's say it, in the blood. So all of these are helping us to regulate our electrolyte balances in our blood. Aldosterone is by far the most common specific one. We have our class, we have a specific one. And, hopefully it should go without saying, how do you think these are going to be regulated then? Yeah, humorally, exactly. Right? Via whatever the electrolyte level is. So for aldosterone, it's sodium. For other mineralocorticoids, it's other electrolytes.
Does it only bring the sodium levels down, or?
Great question. No, aldosterone, great question, plays a role in bringing sodium levels up. Basically, aldosterone targets the kidney, telling the kidney to bring back more sodium. So specifically, aldosterone maintains high sodium levels, which you think about it, we need. If you think about most of the functions that we've talked about cells, one of the major driving forces of things like an action potential, for instance, is that sodium really, really, really wants to go into the cell. And the reason it really, really wants to go into the cell is not just that the cell is negative on the inside, but there's a very high level of sodium in the interstitial fluid in the blood. So to keep doing work, for those co-transporters to do work, we need to maintain high levels of sodium in the blood. So aldosterone tells the kidney specifically, bring back sodium, make sure we keep those sodium levels high. Excellent. So we did that. We did that. Yes, aldosterone also plays a minor role in potassium secretion, but again, we're not going to focus and worry about that. And obviously, it is regulated humorally. We'll talk about this more when we get to the urinary system, but we don't have to worry about it now. For now, just focus on the sodium function. All right.
I have a question.
Yes.
Do we have to know like the pathway, like the angiotensin aldosterone?
When we get to the urinary system, we'll talk about those pathways.
Okay.
Yep. All right. Questions on this one? All right, then let's talk about the zona fasciculata. Again, here when we look at the histology, you can see it's kind of more linear, more parallel in the way that these glandular structures are lined up. It may not be as precise as, for instance, like a dense regular connective tissue, but again, remember, you're not going to have to judge this subjectively. This is the middle region of the cortex, so as long as we're looking at the middle region of the cortex, you know we're talking about the zona fasciculata. And as we mentioned, it is going to be responsible for producing a class of hormones called glucocorticoids. Glucocorticoids help us to mobilize our resources to deal with stress. And that dealing with stress is really, all these black pens are horrible, is the key. And I think one of the best ways to show that is by looking at the most common one. Notice as you look, and of course I don't have any black pens. Yeah, that's better. Cortisol. Or what is also known as hydrocortisone. Why might you be familiar with hydrocortisone?
Is it topical for like skin rashes?
Yeah, if you have a skin rash, inflammation, right, from like a poison ivy or something like that, you can put on it. If you have sore muscles, right, you can put that hydrocortisone patch on there, and it helps to decrease inflammation, right? Hydrocortisone, cortisol, primary function is to suppress, well, one of their major functions is suppress the immune response. Why?
Reduce inflammation.
Right, why would you want to reduce inflammation in those cases?
That sucks.
Yeah, absolutely. Right, that bear with an axe walks in the room and you decide to fight it, or better yet, you decide to outrun somebody in the class, and as you're trying to outrun somebody from the class, you trip and roll your ankle. Do you want your ankle swelling up and inflaming like we normally see with an immune response so that you've now become immobile and you can't run? No, if you're in a life or death situation, you don't want that inflammation. You don't want that swelling. You want to be able to keep using it. Yes, you're doing more damage to it, but you figure it's less damage running away from the bear than staying and fighting it. Right? So by suppressing the immune response, it helps us to deal with that life or death situation. So like we said, it is going to go to places like the liver, go to places like the adipose, and it is going to mobilize glucose. So that we have the energy to fight that bear with an axe. It is going to suppress our immune cells so that if we get injured, we're not swollen, we're not inhibited by that. We can again deal with that life and death situation. You may not have thought of it in these terms, but many of you are aware of it, because when you're in college, it is not uncommon to be incredibly stressed by an exam that's coming up in the next week. And so you spend a week stressed and studying and doing all those things. And while you're releasing cortisol during all of that time, you are suppressing your immune response. So the day of the test comes around and you walk into the classroom and half of the class is sniffling or coughing, or the next day you get sick, right, as a result of it. And why do you so frequently get sick the day after an exam or the day before an exam? Because your stress has been suppressing your immune response, allowing those harmful pathogens to get in and making you sick as a result of it. Right? So again.
So it's your fault we're not here.
Can you mute that? No. But so yes, so it is that. So this is that effect, right? We want to, again, we need to. Stress is supposed to be a life and death type of thing, and typically we deal with those things physically. So we still have these things in place to help us to be able to deal with that. All right. Questions on that? Yeah, so remember, we are,
Pulling it out.
well, but it helps us to metabolize fat, and so in that metabolism of the fat, we are breaking down the fat, we're making glycogen in the muscle cells, so that they can use that for the energy. So it is forming that in the muscles, releasing the glucose in the blood for that. Again, getting us ready for that physical activity. So then my question for you is, how is this regulated? Say again? Neurally would make sense, right? We know neural is definitely involved in the immune response, but nerves typically just innervate nervous tissue, not the glandular tissue. Hormonal? Was there a hormone that stimulated the cortex of the adrenal gland? No? What was it? No, not norepinephrine and epinephrine. Only there was a hormone we had learned about, maybe from the pituitary gland, that targets the cortex of the adrenal gland. Adrenocorticotropic hormone, absolutely. This area is regulated hormonally via the adrenocorticotropic hormone. You remember when we talked about the adrenocorticotropic hormone, we talked about how it targeted the cortex of the adrenal gland. Well, now we can be more specific. It actually targets the zona fasciculata of the adrenal gland, causing the release of those glucocorticoids, helping us to mobilize resources for our immune response. All right? Questions on that? All right, that brings us to our zona reticularis. Notice again, not quite ball-shaped, not quite parallel in their organization, kind of just a random mesh, which again, reticular means net-like, mesh-like structure. And this is where things get a little interesting. Gonatocorticoids are the class of hormones that are produced here. Primarily, a class of hormones known as androgens. There are some estrogens that are produced here as well. However, is this the primary location where estrogens and androgens are produced? No. Where are estrogens and androgens primarily produced? In the gonads, right? In the ovaries or in the testes. When we think of androgens and estrogens, what is a potential target for those?
Reproductive organs?
Say again?
Reproductive organs?
Okay, so like the reproductive organs, right? So the maturation of the reproductive organs, maturation of secondary sexual characteristics, right? Formation of like axillary hair and pubic hair and things along those lines. Now, if you're an axillary hair and an androgen or an estrogen comes to you to tell you to start growing, do you really care where that androgen came from? Whether it was produced in the gonads or produced in the adrenal gland? No, it's going to have the exact same effect. And so these androgens and estrogens that are produced here are going to basically have the same effect as they are when they're produced in the gonads. So then why produce them here? Say again? That could be one of the reasons, and there does seem to be some indications that that may be the case, especially with the androgens. The ovaries do produce androgens. We will talk about that. However, again, there is this kind of lack of full understanding of what's going on here. Only a small amount of these hormones are made here. And again, when it gets to their targets, the targets don't seem to care where the androgen or where the estrogen came from. However, you're right, there are some sex differences, right? They believe that these gonocorticoids that are produced here in the zona reticularis may play a role in helping to enhance those secondary sexual characteristics. Again, the formation of secondary hair, the swelling of the breast, the widening of the hips in females, the enlargement of muscle and bone in males, the larynx, things along those lines. But it also may play a role in aggression and libido. Right? So these hormones may play a role in females in particular in aggression and libido. There have been a large number of studies that have been looked at the effect of androgens and aggression. One of the major areas where they've studied this is in rhesus macaque monkeys. Rhesus macaque monkeys have a very, very rigid hierarchical society where there is an alpha male and a beta male and a delta male and a gamma male, and they all have this ranking and they all know it. And one of the things they've done in observing these is they've taken blood samples and they found that the alpha male has the highest levels of androgens. The beta male has the second highest. They've actually gone and done androgen injections into some of the less dominant males, and they move up the hierarchy as a result of that. Right? And they've looked at other rigid hierarchical societies. One of those happens to be the stock exchange in New York City, where there is a very high amount of aggression and a large hierarchy in the individuals involved in stock exchanges, and they've taken blood samples and seen similar correlations between the amount of androgens and the dominance of these stock exchange individuals. Now, as far as I know, they haven't artificially injected any of these to see what happens, but there definitely is a correlation between androgens and aggression, between androgens and libido, sex drive. And so it believes that maybe these help to accentuate this, especially in females, because androgen production in the ovary is, I don't want to say incidental, it is purposeful and it's meaningful, but it's not made to be distributed in the blood the same way. Basically what the ovaries do, as we'll talk about in a minute, is they make estrogen by converting androgens into estrogen. So most of the androgens that are made in the female ovary are used to make estrogens, right? So they're not going to be able to be circulated. So maybe it plays a role in that. But a lot of this is speculation, yes? Maybe, like I said, it's hard to study these things because not only is it hard to know how a chemical reacts with a cell, but when that chemical is reacting from the cell, we don't necessarily know where it's coming from. There's no way that we can tag the ones that are just made in the adrenal gland to see if they have a different effect than the ones that are produced in the gonads. So it's very little is understood about the zona reticularis and exactly what it does. And if we barely understand what the hormone in here is doing, do you think we have any idea how it's regulated? No. Since it's related to the gonads, it is probably hormonal, but that is completely speculation. So you can just put a big question mark, or more importantly, put a big X through it, because you know that's a question I am not going to ask, because quite frankly, we don't know. Yes?
Do we know a specific hormone from the androgens that it produces? Or
No, we'll worry about specific androgens and estrogens when we get to the gonads. Okay? So yeah, when we get to the gonads, we will worry about how specific examples of those there, which is again why I said classes of hormones here as well. Like I said, this is not well understood. What I will tell you, because again I don't want to go too much in depth, the androgen that produced here, right in the testes, it's primarily testosterone. The primary androgen here is not testosterone, so it is a different androgen, but we're not going to worry about that. So again, we'll just hand wave at this region and not worry too much about it. All right? Yes?
So this specific hormone that you
So really, in this case, it's not specific, it's classes. The zona reticularis gonadocorticoids are basically the two classes of androgens, but also estrogen, to a less extent estrogens as well.
So you won't ask us about the targets of the,
Will I ask you about targets for androgens and stuff like that? Absolutely, yeah. But again, they're gonna the targets for these are gonna be the exact same as the targets for the ovaries and the testes. So we'll focus on it more there. Okay. All right. That is the cortex of the adrenal gland. What that leaves us then with is the medulla. Notice the medulla doesn't have that same white coloration to it that the posterior pituitary did. This does look a little bit more like glandular tissue, but it is not. It is indeed nervous tissue. And primarily the cells you find in here are what cells? If only I had a histology list that had the adrenal medulla on it that I could identify what the specific cells found in the medulla are called. Chromatin cells, excellent. Excellent. And they are responsible for producing a class of hormones called catecholamines. I spelled this wrong. It is E. That is a term you may not have heard of before, but you definitely have heard of the specific hormones. What are the two specific hormones that are produced by the medulla of the adrenal gland? Epinephrine and norepinephrine. About 80% epinephrine, about 20% norepinephrine. Remember, norepinephrine is more the neurotransmitter that is released locally by the sympathetic nervous system. 70. Somewhere within that range. Since I said 70 in the lecture, I'll put 70 here on the board. Do the numbers matter? Am I going to ask you that? No, of course not. And what are the targets of epinephrine or norepinephrine? I think we all know the schedule, right? It's pretty simple and straightforward. We're doing a review today. Next week, you've got your group presentations and an exam. We all know the schedule. Give me the targets.
Muscle nervous system.
Heart, excellent. What effect does it have on the heart? Increase heart rate, and what else does it do?
Blood pressure.
Strength of the contraction. What else?
Blood pressure increase.
Okay, well, it affects the blood vessels.
Vasodilation.
Right, some, it depends, right? Some, so we get dilation to which blood, to what regions?
Muscular tissue.
Muscle, where else?
Liver.
Muscle, liver,
Lungs.
lungs, heart. Excellent. But it constricts where?
Digestion.
Yeah, non-essential stuff like digestion, right, urinary, stuff like that, exactly, etc. Non-essential stuff. And so you're correct. There's more constriction than dilation, so the overall effect, again, is to increase blood pressure. What else?
Bronchioles.
All right, dilates the airways. Dilates the bronchioles.
Pupil.
Dilates the pupils. Why?
Let more light.
Yeah, exactly. Those bears with axes are sneaky. So we need to let as much light in as possible so we can discern them from the environment. They like to camouflage themselves. What else? I can think of at least one more good one. Part of that digestion decrease is you get that dry mouth, right? Part of that constriction of the blood vessels is your skin gets pale because the veins in it constrict to send the blood back to the heart more rapidly. But while your salivary glands stop functioning, what glands do become active when you're stressed? Sweat glands. All right. Basically, these are all those things we talked about in our sympathetic nervous system next door. These are all the things we talked about when we talked about that short-term stress response. Yes?
Do we have to state that all in our paper?
I would be fine with, if you get listed a couple of the targets and basically just said deal with the short-term stress response,
Okay.
that would probably be fine.
Yeah.
Yes?
What does it say after digestion?
I don't know, I can't read that. What does it say? Urinary, and then etc. And, hopefully it's obvious, how is it regulated? Neurally via, there you go, neural via sympathetic nervous system. Perfect. All right.
I really thought you were going to scare us again.
No.
You've given him ideas.
Questions on that?
He was quiet for too long.
I saw a lot of hands still working. I was waiting. Alrighty. With that, we are done with the adrenal